Now, when you begin to consider setting up a backup strategy and actually working backups, you need to determine exactly what type of backup fits your particular database installation. Now, you have three backup types in SQL Server. You have a full backup, a differential backup, and a transaction log backup. Now, in a lot of ways, this transaction log backup is similar to what you've known maybe as a network administrator or whatever as an incremental backup, and I'll show you why a little bit later on. Let's take them one at a time now and just go through them. First of all, with a full backup, this is also known as a database backup. So when you read in any kind of documentation about a database backup, they're talking about a full backup, but there's a couple of things to keep straight here. First of all, the full backup does back up the entire database and, get this, enough of the transaction log to provide recovery, which means it's not actually backing up the transaction log. It's backing up all the data in the database and enough of the transaction log to provide recovery. Okay, so it's not truncating the transaction log either. Now, the rub against full backups, and you always need a full backup, let me go back to that just a second, is that full backups usually take the longest time both to back up and to restore because you're backing up everything. So if you got a large database, it takes the longest time. Now, a differential, as it turns out, is usually the most popular choice. Keep in mind, though, this has to be used in conjunction with a full backup, and here's the plan. We do a differential backup after we have a good full backup in place. Notice, for example, if on Sunday night we do a full backup, so we did a full backup. Then on Monday night we do a differential, and this differential is going to get only the things that have changed since Sunday's full backup. So then on Tuesday night we do another differential backup, and it gets everything that changed on Monday plus the things that changed on Tuesday. Then on Wednesday we do another differential backup. It gets everything that changed on Monday, Tuesday, and Wednesday. Then if we have a failure on, say, Thursday, then all we have to do to get back to where we were is restore our full backup and one differential, our last differential backup, and we're back up to where we were. So differentials, the real time savings has been right here. It's not taken very long at all to do these three backups. So differentials save you some time on the backup process. They also save you some time on the restore process because you only have one file to restore. Now, keep in mind, I've already pointed out that differential only captures data that's changed since that last full backup. It does that by setting an archive bit on every piece of data. And when it reads, it starts to look for an archive bit that has been set because the full backup clears those bits, and then when data is changed, that bit is turned on. So the differential simply goes through, looks for bits that have been turned on, and backs that data up, and it does not reset it. Only the full backup resets that archive bit. Then the last backup type is the transaction log. And again, this is similar to incremental backups because we're only getting what changed that particular day. Okay? Now, if I do a full backup on Sunday night, then I do a transaction log of just what changed on Monday. Then on Tuesday, I do again just what changed on Tuesday. Then on Wednesday, I do another transaction log, and I get just what changed on Wednesday. Notice what happens. If we have a failure on Thursday, we have to first restore the original full backup. Then we have to restore each one of the transaction log backups that we have in order. And we have to replay them in order. And it basically just replays all the changes that have been made. Now, here's the big advantage. Extremely fast to back them up right here. Now, it's going to take you a little longer to restore them because you have to restore 3 files along with your full backup. So that's kind of the rub on transaction logs. A lot of people like transaction logs. They'll run 1 or 2 transaction log backups during the day if they've got a busy database. Notice, though, that a transaction log backup captures only changes since the last transaction log backup, and this clears committed transactions from the log. If the transactions have been committed, they've been written into the database, they're truncated from the log after the backup is completed. So your log shrinks, and you've got them in the backup, but you don't have them in the log anymore. Now, you will hear one other term that I want to point out to you. It's called a tail log backup. If you remember my situation a minute ago, we did a full backup on Sunday, and then we did a little transaction log backup on Tuesday, Wednesday, Monday, Tuesday, and Wednesday. If we have a failure on Thursday, let's say that at 2 o'clock in the afternoon we have a failure on Thursday, there was a little bit of information in that transaction log on Thursday before the failure happened. We need to back that up because it contains the last little bit of transactions that'll get us back up to the point of failure on Thursday afternoon, if that makes sense. That particular backup right there on Thursday is called a tail log backup, and you do that backup when you get to the scene of a server crash. So there's the backup types that you have to choose from. You'll have to decide which strategy works for you and your organization.